Ciao friends! In this video, I want to show you how to solve a common problem, that is ranking based on multiple columns. DAX offers you the rankx function, but rankx works with only one expression. We want to rank based on multiple expressions, and this requires quite a lot of code, depending on how complex your requirements are. Before diving into the DAX code, let's start by reviewing together the requirements. I'm using the rounded sales measure. Rounded sales is nothing but sales amount, but it is rounded to the nearest thousand. This way it introduces ties. Now, because we have ties, you see that we have several rows with the very same value for the sales amount. Rounded sales shows 6,000 for 3 different rows. If we were to use the rankx function, all these rows will have the same number. Instead, what I want to produce is a different ranking, a ranking which is based not only on sales, but also on code and on name. So the first problem that we need to solve is to produce a rank based on 2 columns. Moreover, there is another challenge. Code is a number, whereas name is a string. You will see that ranking based on 2 numbers is much easier than ranking a number and a string together. So the second problem we need to solve is rank on integers or on strings. And then we still have another detail to worry about. The numbers that you are seeing here are using measures. We have 2 measures. Therefore, a slicer which is filtering by Northwind traders works just fine, and the ranking that I produce is actually ranking in a local way, in a filtered way. So my measure is feeling the filter coming from the slicer. If we do the ranking with a column, which is actually simpler, we will not have this feature. So ranking with a column or ranking with a measure produces different DAX code. Therefore, the third variable we have to worry about is whether we want to use a column or a measure. We will go in order of complexity. The easiest code that we can write is the ranking based on 2 numbers in a calculated column. Then we will move a step further and do the ranking in a column with a number and a string. Once the algorithm is well established, then we will go on the next level and we will do everything with a measure. As you will see, the end code is quite complex to author and understand. But if you follow step by step the complete algorithm, then it will be much easier to implement it in your model. Ready? Let's get started. Let's start by solving the first scenario. A calculated column that creates the ranking based on sales plus the customer code, 2 numbers. I already have created a calculated column in customer that contains the rounded sales as customer sales. Now, what I want to do is combine customer sales and the customer code into the same expression so that I have a good sorting to produce my ranking. What can I do? Well, I could sum the 2 values together. But if I were to do that, I would sum a sales amount with a customer code, producing a meaningless result. What I could do is shift the customer sales enough in order to leave space for the customer code. So I will basically add zeros at the end to leave space so that when I add the customer code, the code will replace those zeros and produce a number that has as the most relevant part the sales and as the least relevant part the customer code. That I can do. So I can create a new column in customer. Where is customer? Here. New column. It will eventually contain the ranking, so we call it already ranking on sales and the code. And it contains the customer sales. Shift, let's shift of 100,000 plus the customer code. this expression produces a number that I can actually use to produce my ranking, because the most important part, the most relevant part are the sales, and the least relevant part is just the code. So this is a good number to produce my ranking. Nevertheless, it has a problem because I'm hard coding in the measure this value of 100,000. How do I know that 100,000 works well? Well, what I did is sorting by customer code descending, and I see that the largest customer code is smaller than 100,000, so I can use this number as a good shifter. But in the real world, I cannot use 100,000. I need to use a number which is dynamically computed. And I can follow the same process. I search for the maximum value of the customer code, and I use that as a shifter. So if I update my data, it will still work. So I can create a variable, let's call it maximum customer code, which is the max of customers customer code. And then I return the same expression times max customer code. Now, when I hit enter, the number will be no longer so easy to read, but it works just fine. I can now sort descending. You see that this number is impossible to understand. It doesn't have a meaning, but it is still good. It has the same property that I can use it for a ranking. And this is exactly the next step. Next step, we transform this expression in the proper ranking. Instead of returning this value, we create another variable result, where we now use rankx to rank all the customers based on the expression. So we rank all customers based on the expression we authored. And finally, return result. We need to sort it ascending now because I want the best to be the first. And you see that Lion Wesley with 13,000 is ranked 1. Then we have 1, 2, 3, 4, 5. The number grows nicely. And even when we have ties, like here, where we have 6,000, 6,000, 6,000, the ranking produces 6, 7, 8, 9 in a correct way. The only thing is the format string. Actually, this is not a currency, it's a whole number. And I solved my first problem, ranking based on the sales and the code. Now it's time to look at the second step, which is ranking based on the code, basing on sales, plus the name. The problem with the name is that name is a string. So I can no longer use these mathematical operations using strings. I need to do something different. What I need to do is transform the string into a number. If I'm able to transform the string into a number that still has the same sort order of the string, then I will be able to use the same technique that I used now with the string. So what we will need to do is first create a number that has the same sort order as the name, and then use the same technique we used earlier in order to rank based on two numbers. Producing a number that has the same sort order is actually easy, because what we need to do is create the ranking of customers by name, and that will contain will have the same sort order. So we go in customer and we create a new column, which we call name ranked. That just does a rankx over all customer based on the customer name. And now I have my number. Let's sort descending by this number. And you see that Adams, I need to go a bit there. Adams Arum, which needs to be the first, is actually ranked worse. This is exactly what I need, because later I will use this number to produce another ranking, and I want the highest to be ranked best. So Adams Arum, being with the highest value for name ranked, will actually be the first in the sort order. It is also worth to note that I added to the name also the customer code. This way I always have unique names and my ranking process works just fine. If I had duplicates, that would be a problem because I might have two customers with the same ranking value, which is not good because it will not produce correct sorting later. Now that I have my named ranked column, I can actually replicate the same process that I did earlier. I copied the code and I now create a new column again in customer. That will be very close to what we wrote earlier, but instead of using customer code, it will now use the name ranked. So here we use name ranked. We also change the name of the variable. It's not the customer code, it's max customer name ranked. We use this new variable here, and we do not add the customer code. Instead, we need to use name ranked. This expression is very close to what we did earlier. I just changed column names and I used the column that I created earlier. Of course, I need to change the name, just ranking on sales and name. Now let's sort this ascending. And now you see that ranking on sales on code has this way of growing that depends on the code. Ranking on sales and name, on the other hand, depends on the name. So among the 6,000, Barn Sarah is the first one. Among the 6,000, yes, it's the first one, ranked 6, before G, then M, P, X, and so on. So now I have a column that produces the ranking mixing numbers and strings. I can use these columns just fine. So I can go in my report, add the ranking on sales and code and the ranking on sales, and I need to reduce the font a bit. Okay. I have now ranking on sales and code, ranking on sales and name. The two numbers are different. I honestly prefer the ranking on sales and name because that still leaves to the user the feeling that they can understand how the ranking happens, because you typically have the customer name and alphabetical sorting comes very naturally. The problem of this solution is that it is still using columns. Because it is using column, the all ranking happens based on the column containing the customer sales. So if I apply a filter, let's say, for example, that I filter Northwind Traders, I filter Northwind Traders. Now, this ranking, first of all, does not longer starts from 1, it starts from 3. But worse, the numbers are wrong, because the ranking is not based on numbers that I see on the screen. I see 9,000, but the ranking is not based on 9,000. It's based on the sales of this customer over all the products, regardless of the filter which is happening. If I filter Contoso, for example, or if I filter AdventureWorks, you see that the numbers are completely different because my calculated column is not using the numbers that I see on the screen, it's using its internal numbers. Solving this problem requires going one step further. That is, writing everything with measures. And that's exactly what we are going to do in the next step. Let's do the next step, which is creating the same calculation, but this time dynamic with a measure. Now, the problem of building a measure is that we can no longer rely on calculated columns. So we are not able to have the customer sales calculated column that we used earlier. Therefore, what we will need to do is rebuild the same table that we see here on the screen in a temporary variable inside our measure, so in order to use that for the ranking. This requires a bit more code, even though most of the code, not most, but some of the code is close to what we did earlier. So let me copy the previous calculated column and we start creating a new measure. Now it's ranking on code as a measure. We need to think about the fact that now this is a measure. It's no longer a calculated column, so it will be executed in a filter context, and the entire calculation needs to be bound to the filter context. The first thing we need to check is that there is actually only one customer visible. If there are multiple customers, we cannot compute the ranking. It would be wrong. So first of all, we check that there is only one customer visible. We check that there is actually one code. And because the ranking will be visible also for customers with no sales, they will be ranked worst, but they will have a value for the ranking. We also check that there are actually sales. Otherwise, we just get rid of the value. If we are in this scenario, then we are fine. We can compute the maximum customer code. But again, we need to pay attention to the fact that now we are in a filter context. We're no longer in the raw context of the calculated column. So max will not return the maximum code of all the customers, but the maximum in the current filter context. And because there is only one, that will be the same customer code. So here we need to get rid of the filter context by using remove filters. Next step is building the lookup table that need to contain the customer code, the rounded sales amount, and the expression that I use for the ranking. So let's create a lookup table, where I use add columns to add to the customers. Well, actually not the customers, because I want the lookup table to be larger than the current filter context. So all selected customer. We want a new column, which we call rounded sales, that contains rounded sales in the current filter context times the max customer code plus the customer code. This is the same expression that I had earlier. Now that I have the table containing the column that I use for the sorting, I can go straight for the result and use a rankx, this time over the lookup table, based on the column that I computed right now. The algorithm is finished, but I need to pay attention to one detail. If I use it as it is now, I will obtain an error. Let's check it. Yes, it says that the value for rounded sales cannot be determined. Either the column doesn't exist or there is no current row for this column. This error is kind of hard to understand at the beginning. The problem is this rankx. Rankx is iterating over the lookup table and computing the rounded sales expression for all the rows. This part of rankx works fine. But then we have the last step. Rankx computes the same expression outside of the iteration in whatever context was available outside. When we did that in the calculated column, everything was working fine because we were computing it in a row context that provided a value for customer sales. Here we cannot because rounded sales is valid only during the iteration and it's not valid outside of it. So we need to use the third argument of rankx and compute earlier the number that we want to compare. And the number we want to compare, let's call it current value, contains rounded sales times max customer code plus, and again, here I cannot write customer code. I cannot write it because, again, I don't have a row context. But because I checked earlier that there is actually only one customer code visible, I can use selected value. That shows us an error, but it's actually not. Oh, yes, we need a space here, customer code. Not yet, but it's probably going to go away when I hit enter. And then I use here the current value. Yeah. If I did everything correctly, now this is a measure that ranks based on two different columns. Let's check it. I can take ranking on code as a measure. We sort by rank. No, we sort ascending, and it's kind of working. 13,000 is first, then 10,000, 9, 8, 7. When we reach 6, this shows always 6,000, but this is ranking nicely. And if I apply a filter like Fabricam, Northwind Traders, or Tailspin Toys, well, there is none, the phone company, or Contoso, you see that the number starts always from 1, and now, most importantly, it is correct. It is computing the ranking based on the same numbers that I see on the screen, so it produces a good result. Now, we could type the entire code of also the last measure, but it's really not worth it. It just takes time, and at this point, you understood the details of how to build it. So it's useful to look at it together without typing everything. The last measure, I should already have it here, does the ranking, the dynamic ranking based on the name. If you remember what we did with the calculated column, there we had two ranking. First, a ranking based on the name, and then a ranking based on the first calculation. This is exactly what is happening here. We compute rounded sales, then we have the check for has one value. Then we create first a column in the customer table, a temporary column in a variable in customer table that contains the name ranked. Then we compute the maximum name ranked, and then we compute the lookup table, which is now based on the max customer name ranked and the name ranked. So the same two steps that we did earlier with calculated columns, we are doing them in a variable right now. We retrieve the current name, we do the calculation of the current name ranked to have the comparison value, and then we produce the final rank X that computes the current value. So as you see, this code is definitely not simple code. You never write this code from the beginning. Whenever you need to solve a complex problem in DAX, it's always a good thing to start from simpler problem. Maybe start debugging and checking with calculated columns where you can check the result and see the full flow. And then once you have a good understanding, you can move to measures. If you now need to rank based on two columns, well, you can follow the video, maybe test it by yourself. And if you are interested in it, go to sqlbi.com. There we will have the article, and you can also download the file so that you can play with them and understand the process better. Enjoy DAX!